All right, hello everyone. So from the previous video, now we have a number of strategies in order to find either the common chord or the common tangent between two circles. So we're going to play around with a couple more examples of this today. And again, we do use the 3, 2, 1 pause method. You give it a go and then unpause the video and see how you get on. So this is a circle. You'll notice a lot of these are given in the general formula. Very few of them now are given the shortened version. Okay, and I want to find the coordinates where it intercepts the x-axis. No, we go y-axis this time, will we? Okay. We go y-axis this time. I think it'd be the x-axis. And the length of the intercept or chord. So in other words, we want the coordinates and we want the length of that. Okay, so we do a 3, 2, 1. Give it your best shot. 3, 2, 1, go. And we're back. So let's see. Let me think. Oh no, I'm looking at the wrong one. Sorry. Okay. That's meant to be the. So yeah, let's have a look at this one then. It's going to be, so let x equal to naught. Sorry, let y equal to naught. So you're going to have x squared plus 0 squared minus 4x minus 6 times 0 minus 12 equal to 0. That's x squared minus 4x minus 12 equal to 0. So we've got x, 6 and 2, or 4 and a 3, 6 and a 2, 6 and a 2, a minus and a plus. So x is equal to minus 2 and x is equal to 8. So that's 8 and 0. And minus 2 and 0. And the difference between minus 2 and 8 is 10 units. Okay. Sorry, what am I saying? 6? 6, that's 8 units. Oh, I got to 10. Sorry, yeah, 8 units. Okay. So that's kind of an easy one to kind of start with. I wouldn't say it's the hardest one to start with, you know. Hope you got that. I'm just going to raise this up a tiny wee amount just to get a little bit more of the video in. So hope that makes sense. Yeah, now we're going to try another one. Try not to waste the paper, if that's okay. So, oh, here we go. Here's a nice one. So, x squared plus y squared minus 4x plus 11y minus 12 equal to naught. So it's sandwiched, okay? It meets the x-axis and y-axis at A0 and 0B. And we need to find A and B. So visualize it for a second. So it's basically sandwiched, isn't it, in between kind of the x and y. Is like a tangent type of situation. So we have to find out where it meets. Okay. So let's find them all. Let's find all the points. Okay. So where it meets the x-axis. Okay. So so it meets the x-axis. So if y is equal to naught, I'm just going to do this quickly. If y is equal to naught, you're going to be left with x squared minus 4x minus 12. Okay, x squared minus 4x minus 12. That's a 6 and a 2. Okay. So obviously, it's going to be A has to be 6, hasn't it? Because it's going to be 6, 0. Can't be minus. it could be minus 2, 0. We'll figure it out in a second. Okay, meets the y-axis. X is equal to 0. So that's going to be y squared plus 11y minus 12. y 12 and a 1. And no, so 11 and that's what I'm going to do here. 4 and a 3, 6 and 2. It's be a 12 and a 1. Plus and a minus. Yeah. Y is equal to 1 or y is equal to minus 11. Okay, so we have 4 combinations. So which combinations are going to work? Okay. If it was the positive y-axis, which one would be? If it was the positive y-axis, which combination would work? If it was the negative y-axis, which combination would work? You know, you could do it that way. So let's say if it's the positive y-axis, then you're looking at 0 and a 1, aren't you? Positive y-axis, you're looking at a 0 and a 1. And the positive x-axis, you're looking at a 6 and a 0, aren't you? 6 and a 0. So in that case, B would be 1. Now, if it was the negative y-axis, you'd be looking at the negative y-axis. You'd have a 0 and minus 11. And if it's the negative x-axis, you'd be looking at what's the minus 2 and 0. So you have all the possibilities there. So obviously, you know, it cuts all 4 of them, but that's what you're kind of looking at. So you have a lot of options there for it. Okay. You've got the general gist of it. I suppose that's the main thing. Okay. Now that's question 9. That's question 11. Oh, here's the nice one. Right. Question 11. This one. We have 2 circles. And we want to find the coordinates of the intersection of 2 circles. Okay, so one circle is this. And the other circle is this. Now remember, these are epic. So what do we do? Stage 1, let's find the equation of the line, the chord that joins the 2 of them. So we're going to change the signs on one of them. Gone. 14x plus 4x is 18x. Minus 10y minus 14y is minus 24y. And minus 26 minus 28 is minus 54. Now, everything there divides by 6, I want to say. 3x minus 4y minus 9 equal to 0. Okay, so that's your kind of generic version. Okay, now you saw me doing this before. This is where we have to get a little bit epic, as the man says. So we're going to have to pop one in. I'm wondering now, is there an easy option here? Let me see. I'm not seeing any easy options there at all. Is there an easy option? No, there isn't really, is there? Damn it. Okay, listen, we're going to have to do this old school. Let's go old school on this and we'll try our best. Okay, so if you remember from before, listen, we'll generate the easiest one possible. 3x is equal to 4y plus 9. X is equal to 4y plus 9 over 3. Okay, that's what's going in. Right, let's get it in then. Okay, so listen, you can pick either of the 2 circles to substitute it in. I mean, it literally will not make a difference which one you substitute it in to, if that makes sense to you. It's not going to in any way kind of, I suppose, just go into the whichever one feels nice. I'm going to go into the top one. Okay, so it's going to be 4y plus 9 over 3 squared plus y squared plus 14 times 4, oh God, plus 9 over 3. These ones, unlike the one I did in the previous video, these ones are built to work out. So even though this looks crazy, it is built to cancel down and be lovely. So don't be afraid to go at it. Minus 10y minus 26 is equal to 0. So this is my starting point, really. I'm going to have to do all this out, okay? So remember, we'll use our same trick. First of all, I can see straight away that everything's going to have to be multiplied by 9 eventually in order to get rid of these fractions, but we'll come to that in a second. Square the top, 16 y squared plus 9 9 is 81, 49 minus plus 72y, Jesus, over 9 plus y squared plus 14 is 56y plus 9 times 14, Jesus, 9 times 14 is 126 over 9, sorry, over 3, minus 10y minus 26 equal to 0. Now that just looks like hell. But anyway, multiply everything by 9. 16y squared plus 81 plus 72y plus 9y squared plus, and everything here is going to have to be multiplied by 3. 56 times 3, 168y, 126 times 3, plus 378 minus 90y minus 26 times 9, 2, 3, 4 equals 0. Ay, 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 ay. Okay, let's tidy this up. 25y squared. Now, 72, 186, 168, minus 90, 150. Okay, it's looking good so far. Those two things are factors of each other. Sorry, plus 150. Okay, and now, when will this end up being a factor of 25? 81, 378, minus 234, 225. Oh, you cheeky, cheeky, cheeky thing. Look at that. Everything divides by 25. So, y is equal to minus 3. Okay, sorry, cut off the end there. Y is equal to minus 3. So, if y is equal to minus 3, how do I find my x? Well, I can go right back up here. Okay, y is equal to minus 3, x is going to be equal to 4 times minus 3 is minus 12 plus 9 divided by 3. Y is equal to minus 1. So it's minus 1 and minus 3. Okay, and it's a tangent. Now, is that epically cool or what? Okay, is that epically cool or what? Okay, so we'll start from the beginning again. You've got two equations, take them away, you get your chord slash tangent, whatever it is, substitute it in, solve, and they listen, you saw from the last video how epically horrible it was, whereas this one is perfection, it's beauty, it's designed this way. So while the last one might have taken you ages, this one shouldn't take you that much time, because you should know you should be getting a half decent answer out of it. No, nothing too crazy or too mad. Okay, so there you have it. That's another example of how to do these ones. They're not too crazy, not too shabby in a way. You know, they're accessible. I suppose that's the best way I would describe these ones. They're accessible. Okay, we'll try another one.